Greetings everyone. I am UDAY SHARMA from the Triply Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic drone-based ceramic insulators condition monitoring. Overhead power lines plays an important role in the modern world as they allow the transmission of electricity from generation sources to users. OHPS or overhead power lines need to be inspected regularly to ensure safe and reliable operation of the power grid. Traditionally, overhead power lines have mainly been inspected visually, where an inspector physically observes the overhead power lines to determine whether the cables, insulators, or overhead power lines accessories have defects. This approach is cumbersome, time-consuming, and dangerous. Furthermore, the approach relies heavily on the experience of the inspector. Like if the inspector is not as experienced as the others, he may be endangered or he may be injured due to the overhead power lines. Using quadcopters or drones to conduct such experiments of power lines and associated equipment may enhance the efficiency of the process and also definitely reduce the risk of the line of a human inspector. Unmanned aerial vehicles or UAVs have seen rapid development in the past few years. Quadcopters are particularly type of UAVs with four rotors. As the commercialization of quadcopters has increased, so has the research into different possible applications of the quadcopters. Quadcopter is considered as a machine with four rotors. This is a rotor of the quadcopter. More or less, the arrangement of a quadcopter is like this. Methodology of working of this real-time monitoring of overhead power line insulator is usually done by installing cameras and remote terminal units or RTUs on the overhead power lines. This is one of the methods which can be done to monitor the overhead power lines. The real-time monitoring units, the remote terminal units, then transmit the data to a distribution control system where the actual computer vision process takes place. The main advantages of using this distribution control center is that it allows user to carry out comprehensive checks on the images being transmitted from the RTU. As a consequence, the computer vision results may be more precise and accurate, thus increasing the reliability of the inspection process. However, there is a disadvantage of the system. It requires a lot of hardware to be installed on the existing power system. Suppose consider a power line. We need to install a camera and a a, mounting system and a cover to the camera to monitor its surveillance and etc. An operational insulator condition monitoring system. In addition to this, the cameras installed on a single tower can be worked on the vicinity of the tower. This means while a particular part of the tower is covered by a camera field of view, there is no coverage in the other part of the tower. That is, this insulator, we have placed a camera here. Only the field of view of this camera is here. We want to monitor the transmission lines of this or any other part of this drone, transmission line. We cannot monitor through the camera. Allows if such camera lenses get affected by the weather conditions, the capability to perform inspection is greatly reduced. Consequently, regular maintenance of the inspection hardware also needed to be carried along with the inspection of the overhead power lines. This is a troublesome process. Like we also need to maintain and inspect the overhead power lines along with the hardware of these cameras and regular maintenance inspection. This increases the overall maintenance cost of the overhead power line system. Compared to this method, the traditional way of monitoring the overhead power lines drone-based monitoring system is easy to maneuver and close to the vicinity of the overhead power lines. And also the images captured from the drone can be analyzed later and can be used to classify the conditions of these overhead power lines. Let's see how the drone-based overhead power lines monitoring works. First, set up the quadcopter-based overhead power lines inspection system near the area of inspection. Suppose let us consider a transmission line. We need to place the quadcopter near here, near the transmission line, or the area need to be inspected. Start ground station computer, the quadcopter's onboard computer and inbuilt communication systems between them. We need to start our computer and the computer in this quadcopter. Then operator sets the flight path. Like this, in the quadcopter observes the whole transmission line. Sets the flight path of the drone so that the drone hovers near the area to be inspected autonomously. The operator only sets the flight path. The drone automatically goes up, revolves, and checks around this overhead power line of this condition. Then the onboard and onshore systems record data and detect overhead power line insulators and classify them according to their condition, like the condition is bad, good, etc. Operator then lands the drone upon completion of the inspection. Overhead observes data and makes necessary conclusions about insulator step. Then, with this our acquired data, with the operator assumes and analyzes the data and gives the condition of this overhead power lines. Then the drone is stopped. Computer vision. The copter-based overhead power lines insulator condition monitoring system relies on computer vision. Consequently, a large set of images is needed for training and neural network used for classifying the insulators according to their condition. The dataset consists of images that are taken at different times during the day to account for different lighting conditions. Also, images of insulators with varying backgrounds are incorporated. The dataset is built considering the expectations that the quadcopter distance from the overhead power line modeling frame is expected to vary between 0.5 and 3 meters. This distance depends on the voltage level of the power line being surveyed and is selected to ensure a safe clearance from the electromagnetic fields affects the close to a power line. Suppose if the car is of higher voltage, it may have the higher EMF, which disturbs the quadcopter, and the quadcopter may have chances of crashing into the power line. Object detection techniques involving regional convolutional neural network or RCNNs are computationally heavy because of the large number of processes embedded within the use of RCNN. These processes can be expected by using GPUs in the computer. As we can see here, there is a broken insulator, there is an healthy insulator, and a dirty insulator. The drone all absorbs everything. There is the goalpost, the background, everything. We have seen this is a wrapped insulator, meaning it is a dirty insulator. Then the drone, the onboard camera analyzes it. If it with the different inputs it has been given, if it was an aeroplane, a car, or the dirty insulator. According to the inputs it gets, we know that this is a dirty insulator. So it gives the output as dirty insulator. Hardware. The hardware components of the overall system can be divided into two parts. The first part focuses on the hardware over the quadcopter. The second part is the hardware required for the onshore processing. Quadcopter system. A quadcopter, or namely Gapter, which is the drone used in this process, with onboard computer available of the robot operating system or ROS availably selected. The use of robot operating system can allow a user to extract essential information from the quadcopter and communicate it to the ground station running ROS without the need to be a lot of software configuration. The onboard computer system called Odroid XU4 allows the USB camera to be attached to the quadcopter so it can visualize and take the pictures of these insulators or anything. In addition to this sacrificed foam legs and this sacrificed foam platform are attached to the existing legs of the drone to protect the main body from the damage in case of rough landings. Suppose there is a drone, it has legs and four rotors. There are external protectings to these rotors and the drone's legs, so that if any damage occurs to this side, it loses only the external foam legs and the external sacrifice foam platform, and the internal drone parts are safely attained or acquired. Furthermore, propeller guards are also attached each arm of the quadcopter, as discussed earlier, to protect the propellers from breaking in case of minor crash. As we can see here, there are propeller guards. These are called the propeller guards. This is a Raspberry Pi and power bank attached to the drone. This is the camera. These are the foam legs attached to the platform. User-operated RC or remote control transmitter is attached to it. Onshore processing or ground control, it sends the data from the cameras and GPS locations to the remote operating system through a router. It reaches to the ground controlling station. This Raspberry Pi analyzes the camera's data and sends to the through the RO system sends to the router. Working calibration. Let us discuss all the working steps finally of this drone-based monitoring system of overhead lines. The user first calibrates the captor or the quadcopter using an autopilot software suite, which makes the quadcopter is an operable condition. The user then initiates remote operating system on the captor and then starts publishing GPS coordinates and images from the captor. Onboard computer. The user then starts the Raspberry Pi on the captor and makes sure that the computer vision algorithm is running on it. Onshore computer. The user then starts the ground control station to receive images from the Android via ROS. Captured images flow. The images from the Android are usually used for onshore processing on the ground station, and the images from the Raspberry Pi are used for real-time onboard classification of installator health condition. These two pathways of image transmission to the two different image processing mechanisms. Carrying out the inspection. The user maneuvers the quadcopter to an area where the inspection needs to be carried out and lets the drone hover autonomously around the area for some time. Landing. Once the inspection is completed, the user can then land the captor drone and turn it off. Data examination. The user can then examine the results of insulator health classification from data on the ground station. Also, data on both the drone's Raspberry Pi computer can be examined remotely, logging into the retrieving onboard memory stick. Let us conclude this topic by saying that we can see how the drone-based quadcopter-based monitoring is of the overhead lines can be done. You also know that not only does work of monitoring the overhead power lines, it also does it more efficiently, more safely compared to the traditional methods of like one man or instructor uh, climbing over the insulated lines or any camera-based, computer-based monitoring systems. And also the software can be furtherly developed and more inputs or more test inputs can be given to it so that the outputs are highly efficient of this drone-based monitoring system. Thank you. This is UDAY Sharma signing off.